Hi, welcome to session 10 Zoology subject, the third chapter, session 10. Now we'll see here some exercise on blood grouping. Now we'll see exercise on a blood group. Look at here. What do you mean by this? It means what are the possibilities? That is, now we'll see the male and the female individuals. All this what I am going to say is what are the possible combinations that are seen in the progeny. If you have this exercise, definitely you can score in the competitive examination. Particularly some of the questions definitely expected in this record. So far what blood groups we have seen, I'll list out blood groups and the number of antigens. We'll see number of antigens. A question you may be also expect from this corner. Look at here. A positive will have the number of antigens are 2. Why? A blood group is with A antigen in its RBC. Positive indicates RH antigen. So the number of antigens in A positive is 2. Next, A negative means this is the blood group A without antigen, without RH antigen, but A antigen is existing. So the number of antigens are 1. Next, B positive, B antigens and RH antigens. So the number of antigens are 2. Next, B negative, the number of antigens are 1. Is it right? Why? B negative in the sense they are with RBC, B antigen, but no more RH antigens. Now, AB positive in the sense AB is the blood group with antigen A, antigen B. So 2 additional RH antigens. So the number of antigens are 3. 2 plus 1, 3. Next, AB negative. The number of genotypes will be A and B antigens. Number of antigens 2. Next, O positive is with one number of antigen, that is RH antigen, whereas the O negative is nil, no antigen. So in this connection, all the blood groups are ABO blood grouping system is with the 4 phenotypes, 6 genotypes, 3 alleles. In this connection, A, B and O, 4 phenotypes possibly are there, and let's find out the number of antigens they possess. A positive is with in its RBC is with the A antigen as well as RH antigen. So number of antigens are 2. A negative in the sense they are with A blood grouping related to the ABO system, and RH blood group they are without antigen. So they are with the one antigen, that is A antigen. B positive means in terms of the ABO grouping system they are with the B antigen. In terms of the RH blood group they are with RH antigens. So number of the types of the antigens are 2 here. Number of types of antigens, what here you have to find out is number of types of antigens. And B positive is with B antigen, RH antigen 2. B negative with only B antigen in its RBCs. So number of types of antigens are 1. AB positive, A antigen, B antigen and RH antigen. Number of types of antigens 3. AB negative, A antigen, B antigens, no RH antigens. So the number of types of antigens are 2. O positive is with the naturally in ABO grouping system, O blood group is without antigen. But here it is with the RH antigen. So number of antigens are 1 and O negative is nil. So in this connection, O blood group is without antigen. So if majority of the populations are RH antigens, is it right? So O negative, if it is there, it is considered to be the universal donor. Why? It is not with the antigens. So O negative is the universal donor. O negative is said to be the universal donor. Universal donor. Whereas in the same way, AB positive, the donor should not with the antigen. In the same way, the recipient must have antigen. Why? RH antibodies are produced when the recipient is RH negative. So what care is to be taken? The recipient should not be the negative. So AB positive individuals are said to be the universal recipient. Universal recipient. And one more point also, I explained that AB blood group only serum are also considered to be the universal donor. This is the point to remember. Now you are clear with why O negative is a universal donor and AB positive is a universal recipient. Now let's go to the different types of combinations that they have. Right. If the father is with the A blood group and mother is with the O blood group, what are the genotypes we find? IA, IO and IO. Generally, we have to take into consideration heterozygous type, as A can be IA, IA and IO. If we take a heterozygous, the different possible combination can be seen. So IA is one allele, IO and IO from the female parent. So we find IA, IO and IO, which means for the blood groups of A and O, what are the possible type of the blood groups are possible? A and O. A and O are possibly seen. Now let's see if the mother and father are. Father is with the B blood group and the mother is with the O blood group. Again, IB, IO. So, IB, I or IO. So, it results in a IB, IO and IO. Right? Next, let's see the father is with the AB blood group and mother is A blood group. I'll give few of the combinations, remaining you have to follow. You have to do at your working time, that is as a homework you have to do all the possibilities. I'll give a maximum of the combination, remaining you have to try. You have to do at home. The father is with the AB blood group and the mother is with the A blood group. Let's see IA, IB and IA, IO. As I already told you, when it is a B and a A, You have to take into consideration heterozygous. Why? For suppose if I take the A itself here, so all possible combinations are only A blood group. But if you take into consideration IA, IO, I repeat, if I take IA as a homozygous dominant blood group, all the generation, all the progeny produced will be A blood group only. If you take into consideration heterozygous, then the more possible combination is happen to be takes place. So more possibilities are there. Now here IA, IB and IA, IO. So look at here, what possibilities we see is 1 A blood group is possible. Next A is possible. Next AB possible. Next B possible. Look at here. If the father is AB and mother is A, AB is denoted as IAIB, A is denoted as IAIO. So the possible progeny is A, AB and B. If we see AB and B, naturally what we observe is the AB and the B. Look at here, IA, IB and IB, I. So this is AB, A, B and B. Look at here. So by all these combinations, one point to remember, if one of the parent is with the AB blood group, if one of the parent here AB, here AB, if one of the parents is AB, is there a possibility of O blood group in the progeny? No. The point to remember, I stress upon this, if one of the parents is either mother or father, if one of the parent is AB, is there a possibility of a O blood group in their progeny? No. So a combination, you may be asking questions like this: if one of the parent is a AB blood group, is there a possibility of O blood group? No. Next point, the progeny, there are children for a couple, no children is with O blood group. So what is the possibility that one of the parent is definitely with one blood group? I repeat, in a family, the children are with none of them is with the O blood group. What is that one of the parent is with a compulsory blood group? What is the answer you raise? The answer you say, it is if one of the parents is with the AB blood group, no children is with the O blood group. Next is that one more point to remember, A and B. If we go for the another combination A and B, look at here, A and B. In this connection, if we see A and B, what you come to know? IA, IO and IB, IO. Look at here, IA, IO, IB, IO. Look at here, this is AB, is it right? AB, next A, next B, next O. How many blood groups are there in the ABO blood grouping system? ABO blood grouping system is with the 4 phenotypes 1, 2, 3 and 4. So, if the parents are with the heterozygous AB blood group, all possible combinations are there. I repeat, if the parents are with AB heterozygous blood group, all types of the phenotypes of ABO blood grouping system is possible. So here also you can ask a question that for a couple, all the 4 types of blood group progeny are possible. Under what conditions? What are the type of the blood groups of the parent? If the progeny have all the different types of ABO blood grouping system, nothing but AB, A, B and O. It is none other than A and B. The parental blood group is A and B. Even if you go for any combination, no blood group will have all the 4 types. It is possible with the A and B. Let's see if we go for the A, B and O. A, B and O. I'll write here itself. A, B and O. If you see here, what is the genotype? IA and IB and IO. I repeat, AB and O. Look at here, IA, IB and IO. So what is the possibility? That is none other than A and B blood group is possible. If the parents are with AB and O, they are with A and B. So this is all what the different possibilities of the blood grouping system. An exercise on this. The different possibilities. For suppose, if the parent is with the A blood group and another parent is with O, A is denoted as IAIO and another is IOIO. So IAIO and I. So the possible genotypes, the possible genotype is IAIO. None other than the phenotypes are A and O. If the parents are with A and O blood group, the progeny possible is A and O. If the parents are with AB and O, the probability of the blood group is none other than B and A. Look at here, IA, IB and IO, IA, IO, IB, IO. So B and O are possible. Next, if the parents are with A, B and A, look at here, IA, IB, IA, IO. So IA, IB, IA, IO. So all the possible combinations of the progeny are IA, IA, nothing but the A, IA, IO, nothing but A, IB, IA, AB and IB, IO, B. Next, if the parents are with AB blood group with the top of the B, AB and B, IA, IB, IB and IO. So possibilities are AB, A, B and B. The only thing, if you are thorough with the type of the genotypes, that is with the IA, IO, IA, IA. For this combination oriented, that is for finding of the blood groups of the progeny, for A and B, you have to take into consideration heterozygous status. And that's what the another combination. If the parents are with the A blood group and B blood group, A, IA, IO, IB and IO. So IA, IO, IB, IO. So AB, A, B and O. So all possibilities are seen for such parents. So by this you come to know that if the one of the parents is with the AB blood group, no progeny will have the O blood group. One condition. Next, if the parents are with the A and B heterozygous, all possible blood groups are what possible? Which means if one of the parent is O blood group, the progeny have a chances of O is there. Is it always right? No. This is what I am saying. You should be very careful. Even if the case with AB and O, if you see AB and O, ABO is a condition in which one of the parent is O, but no baby born will be O blood group. They are with either A as well as the B. So I repeat that in order to have the O blood group, there is a possibility that one of the parent is O and another parent should not be AB. As I already told you, if one of the parent is AB, none of the progeny is with the born of O blood group. So 2 points to remember, that one of the parent is AB, no progeny will be born with the O. And if the parents are with A and B blood group, all the 4 phenotypes are produced. So this is what all the exercise related with that of the blood group. So in this combinations we have seen that the A is the blood group and another is with the B blood group. If the parents are AB, the possible genotypes are, the possible blood groups will be AB, AB and the O. Next, if the parents are with the A and O, look at here. This is possibility of the blood group, and another is not possible. Not possible. The possibility and not possible. Not possible. So in this connection we see that if the parents are with A and B blood group, all possible blood groups are seen, but the not possible is not implied. Look at here. The second combination, if the parents are with A and O, what are possible? That is, if we see IA, IO, 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 which means A and A, O and O. So what are possible? A and O are possible, and what are not possible? B is not possible. At the same time, AB is not possible. Is it clear? In order to have AB blood groups in the progeny, parent must be with A and B antigens. Mother should be with the A antigen, or else B. Father should be either A or B, then only it is possible. So if the parents are with A and B heterozygous status, the AB is possible. But here there is no such condition. So for A and O parents are, what possible blood groups are seen? A and O. What are not possible? B and AB. In the same way, let us see if the parents are with the B and O. what are possibility is the B and O. For suppose IB, IO, B and O both are possible. What are not possible? That is A is not possible and AB is not possible. This is what we see. Next, if we go for the another combination, A and AB are the parental the generation. Next, here what is possible? IA, IB is with the parental combination. Look at here. A is possible, AB is possible, A is possible and B is possible. Is it right? If the parents are A and AB, what are possible blood groups we see here? That is A, B, A and AB. So these are what possible. No need to repeat the same. A is 50%, B is 25% and AB is 25%, which means all possible combinations are A, B and AB. Then what is not possible? The only thing is O. So here where the point I explained earlier, if one of the parent is AB, there is no possibility of the O blood group. This is what the questions have a chance of asking in the examination. If one of the parent is AB blood group, no chance of the progeny born with the O blood group. If one of the parent is AB, no progeny will be with the O blood group. Next, the same thing with B and AB. So the same thing is repeated. That is none other than IB, IO, IA, IB. So AB is possible. Same like earlier, AB is possible. Right? Next, the A is possible. Next, B is possible. No possibility of O. Same thing. Next, if we go, the AB and O, let's see. So here the question, if one of the parent is O blood group, is that progeny have the O blood group? And the condition you have to see, the another parent should not be AB. If one of the parent is AB, no progeny is with the O blood group. So no chance. IA, IB, IO. So possibilities are A, next A, B and B. So only AB is possible. A and B is possible. What are not possible? AB is not possible and O is not possible. This is the remind of you. However, look at here. So these are all what indicating the possibilities of the progeny. It is that the parental combination may not be repeated as it is in the progeny. Look at here. AB and O are the parents. What is the possibility? A and B only. IA, IB is the genotype for AB. IO. So A and A, B and B. Is it right? So what do we find here is, for AB and O parental generation, for which only AB is possible, AB and O are not possible. This is all what the possibilities, that is exercise on the ABO blood grouping system. So In this connection of ABO blood grouping system, we have seen so far it is the best example for multiple allelism, and ABO blood grouping system is with the 3 alleles IA, IB, IO and 4 phenotypes A, B, AB and O, and 6 genotypes IA, 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 IO, IB, 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 IO, IA, IB, IO, IO, 6 genotypes. And we have discussed the ABO blood grouping system, in which O negative is a universal donor, and AB blood group positive, AB positive is the universal recipient. Agglutination is a condition which is the genetic incompatibility results in agglutination. Genetic incompatibility in the sense the inability of coexistence of 2 different blood groups. That is, if the mother is with the what is called a RH positive blood group is the father. Be careful. Father RH positive, mother RH negative. They are the 2 different blood groups. They cannot coexist. They do not exist together. As the baby is with the RH positive itself, this sensitizes the mother immune system, and RH antibodies are produced. As naturally RH antibodies do not exist when positive blood exposed to RH negative. In RH negative individual they are produced, this leading to the HDNB erythroblastosis fetalis. So RH positive, RH negative individuals are phenotypically normal, but blood transfusion and pregnancies during the same, the genetic incompatibility results in the consequences, that is RBCs are ruptured. So HDN erythroblastosis fetalis is the genetic incompatibility consequences in the fetus, as the fetus is RH positive and the mother is the RH negative, and it is a alloimmune disorder. As I already told you, alloimmune in the sense it is an immune system disorder between the same species but different individual. As we have seen one more example, autoimmune disorder, and the probabilities of the progeny that are produced and the number of the genotypes we have seen. In this connection, one point let me clear you, that is of all the blood groups so far we have seen, AB positive is with the highest number of antigens. AB positive. AB positive with the A antigen, B antigen and RH antigen. The blood group without antigen is O negative. So the highest types of the antigen, AB positive, is the universal recipient, and the blood group without antigen, O negative, is the universal donor. And the different possibilities, if the parents are with A and B blood groups, the probabilities, all possibilities, A and B heterozygous, all possible blood groups have a chances. Next, if the parents are with A and O are possible, B and AB are not possible. If the parents are with B and O are possible, A and AB are not possible. If the parents are with A and AB, one of the parents, if AB, the possible blood group is A, B and AB, but there is no chance of O blood group. Again, B and AB, A, B and B, A, B and AB, O is not possible. It indicates that if one of the parents is AB, progeny have no possibility for O blood group. If the parents are with AB and O, A and B are possible, AB and O are not possible. Thank you.